In this lesson, we're going to be talking about the perimeters and areas of similar figures. The success criteria is I can use corresponding side lengths to compare perimeters of similar figures, I can use corresponding side lengths to compare areas of similar figures, and I can use similar figures to solve real-life problems involving perimeter and area. Perimeters of similar figures. When two figures are similar, the value of the ratio of their perimeters is equal to the value of the ratio of their corresponding side lengths. Okay? So we talked about the ratio of corresponding side lengths of similar figures in section 2.6. And this is just saying that the ratio of the perimeters of our similar figures is going to be the exact same ratio as the ratio of each corresponding side length. So in this case, side AB, that ratio to side DE is the same as your perimeter, same as BC to EF, same as AC to DF. So for example 1, all we have to do is find the value of the ratio, red to blue, of the perimeter of the similar rectangles. Well, I know these are similar, and I know that the ratio of the perimeters is just going to be the same as the ratio of the side lengths. So even though I only have one side on each one, I know that these are corresponding because these are both the shorter sides of the rectangle. Okay, so I know that 4 corresponds to 6. I know that the perimeter, my ratio of the perimeter, is the same as the ratio of these side lengths. So for red to blue, I know my ratio is equal to 4/6. That's going to be the same ratio as my perimeters, the perimeter of red to the perimeter of blue. But notice, I have a fraction that is not simplified, okay? And by the way, I do want you to write your ratios as fractions, okay? And this is not simplified, so I have to simplify it. So this simplifies to 2/3, because I can divide a 2 out of the top and bottom. So anyway, the ratio of the perimeters of red to blue is 2/3. And now we're done with this one. Areas of similar figures. When two figures are similar, the value of the ratio of their areas is equal to the square of the value of the ratio of their corresponding side lengths. So I have a very corny and cheesy phrase for this. I like to say area squarea. Whenever we're figuring out the relationship between similar figures' areas, you just take the ratio of the side length and then you square it. Okay, so that's why I say area squarea. Anyway, the area of triangle ABC over the area of triangle DEF, that's the same thing as side AB over DE, that entire quantity squared, side BC over EF, that entire quantity squared, and then AC over DF, that entire quantity squared. And the reason this is the case, I'll just show you, you don't have to write this down, is let's say that this is our original figure. Okay, let's say that this is double the size. Okay, this is 2 times the size as this. Okay, well, the area of this triangle is just going to be A equals 1/2 base times height. Okay, well, if I'm doubling this, I'm also doubling the height as well. So that means that my area of this triangle, do this one in purple, the area is going to equal 1/2. Well, this is just 2 of these. I'm just telling you this. Okay, so 1/2 times twice the base. And then I know the height's going to be doubled as well because our side lengths are going to be proportional. And that's going to be times twice the height, okay? Well, notice, when I multiply these out, I'm going to have area equals, well, 2 times 2 is 4, and then half of that is just 2. So 2BH, and this is just going to be 1/2 BH, okay? So to get from here to here, I'm not multiplying by 2, which is my scale factor of the side lengths. I'm actually have to multiply by 4. So I actually have to take this 2 and square it. And the reason is because there's a 2 here and a 2 here. So I could write this as area equals 1/2 BH times my scale factor 2 squared. Okay? Once again, you don't need to worry about this, but this is just why it works like that. For example 2, we're going to find the value of the ratio, red to blue, of the areas of the similar triangles. If you remember my phrase, area squarea, that just means that the ratio of the areas is equal to the ratio of the side lengths squared. Okay? So what that means, what I'll write down is the red side over the blue side. Okay, if I take this value and then square it, that is going to be equal to the area of the red. So I'll say the red area over the blue area. Okay, so all I got to do to figure out this ratio is just plug in my side lengths. So the red side is 6. So that's going to be 6, and then over 10 is the blue side length. If I square this, This gives me my red area over my blue area, okay? Well, first thing I'm going to do here is actually simplify this fraction. 6 over 10, if I divide a 2 out of the top and bottom, that is just going to be 3 over 5. So that's 3 over 5, and my quantity is still squared. So 3 over 5 quantity squared, that's just the same thing as 3/5 times 3/5. Well, 3 times 3 is 9 over 25. That's 5 times 5. So my ratio, if I go back up, the ratio of the areas of the similar triangles from red to blue is 9 to 25. And now we're done with this one. For example 3, a swimming pool is similar in shape to a volleyball court. Find the perimeter P in the area A of the pool. Okay? Well, I'm given the fact that the perimeter of the tennis court is 60 yards and the area of the tennis court is 200 yards squared, and the shorter side length is 10 yards. Okay? Well, first I'm going to do the perimeter. Okay, the perimeter is easier. The ratio of the side lengths is going to be the same as the ratio of the perimeter. So I'm going to set up a proportion here. Okay, remember, a proportion is just when two ratios are set equal to each other. So what I'm going to do is the perimeter of the tennis court is 60. And then I'm going to have this go with my 10-yard side length. Okay, so the perimeter is 60, and the side length of our tennis court is 10 yards. Okay, well, this is going to be equal to the perimeter of the entire pool, which is P, over the corresponding side length, which is given to us. That's 18 yards. So 18. Okay, and now all I have to do is solve this proportion to find the perimeter of the pool. Okay, well, first thing I'm going to do before I even cross multiply is just simplify this. Okay, I can just divide this out. 60 over 10 just becomes 6. So I can just think of this as 6 over 1, or just 6. Okay, and then all I have to do to find the perimeter is cross multiply, or I can just multiply by 18 on both sides. You don't need this one here, but if you want to cross multiply, it will be easier this way. So I'm going to multiply these. P times 1 is just the perimeter. And then 6 times 18, I can just do that out. I get 48, and then 1 times 6 is 6, plus 4 is 10. So the perimeter of the pool is 108 yards. Okay, so we're done with the first part, but now I need to figure out the area of the pool. Okay, so I'm going to set up a similar proportion, but if you remember my phrase, area squarea, I'm going to have to square the ratio of the side lengths. So I'm actually going to set up a different proportion. So now I'm just going to do the side lengths. So the side length of the tennis court right here is 10. The side length of the pool is 18. So I'm going to do 10 over 18. Okay, this is the tennis court side length to the pool side length. And remember, I have to square this to set it equal to the area of the tennis court and the area of the pool. Well, the area of the tennis court is 200 yards. Okay, and then the area of the pool is what I'm looking for. So I'm just going to say A. So now I'm just going to solve this proportion. First thing I'm going to do is simplify my fraction right here. 10 over 18, they're both even, so I'm going to rewrite this as 5 over 9. All right, and now that's squared, and that's going to equal 200 over the area. Well, I can do the same thing. 5 ninths times 5 ninths. 5 times 5 is 25 over 81 equals 200 over my area. I could cross multiply here, that would totally work, but if you see here, it's pretty easy to get from 25 to 200. I can just multiply by 8. 25 times 8 is 200, okay? But if I'm multiplying by 8 on the top, that means I have to multiply by 8 on the bottom as well. And if I just do 81 times 8, I get 8. And then 8 times 8, 64. So the area of the pool is equal to 648 square yards. So I found both the perimeter and the area using these ratios, and now we're done.